Okay, I'm ready.
Yay! Well, we're live now, so.
Cool. So I'm using a Chromebook this time, because my laptop is broken. So if I disappear, just letting you know, it's because my Chromebook died. But,
Oh,
but I'll let you guys
okay.
know.
All right. Cool.
Alrighty. Well,
Okay. First problem.
draw a picture.
Yep. Do you guys ever get tired of these?
Nope.
Just like,
I love them.
okay, cool.
Outlook. Yes. Well, I can show
All
you guys
right.
what I put for this one.
Huh?
I'm not quite positive on all of them, but we'll see how this.
It's not. I can't see anything really well.
You see that?
Oh, now I can.
I think as long as you're the one that keeps talking, I think we should be able to view it.
I literally looked at the PowerPoint because I'm still trying to learn which ones are which. But I went through and found everything. I'm still confused on the what it means by two. Was it two leading strands? So I just kind of guessed that it meant daughter and parental.
There's two leading strands. There's the when they split it in half. There's one going one way and one going
Yeah.
the other.
Okay.
So let me draw it
So
real quick.
the two strands of DNA, the parental DNA are the leading then?
Yes.
Okay.
Here's
I'll erase this.
what I got out of it.
Okay.
Let me flip my camera. I think this is. Oops, that's. Okay, can you guys see this? I think this is what they mean by the.
Yeah.
Turn on a light. That didn't help. Yeah, it did. All right, so
Yeah.
this is what I think what they mean by the two forks, because you can have your origin of replication, right, where this is really difficult to do. Right here, where the dotted line is, and you're gonna have one leading strand going this way, and one leading strand going that way, because
And then
this one is gonna create the lagging strands and the Okazaki fragments, and then
yep.
this one is the same deal. Oops.
Okay. Okay.
Okay.
Makes sense. Okay.
Wow, my lighting makes me look like an angel right now. Just kidding.
Okay.
Okay, cool. So we need auric, which was gonna be that DNA primase. Okay, so what are the primers? The primers go before or what?
yes.
Oh,
So DNA. DNA. The primers are for like DNA primase 2 and 3 and all that. I think are for prokaryotes, right? And then
I think
eukaryotes
so.
just use the one DNA primase. And I
I
think that, huh?
go ahead.
I think the DNA primer, it goes like there's one that goes on the leading strand, and then there's a bunch that go on before the Okazaki fragments.
Mm-hmm. Yeah, I was thinking it was the part right before the Okazaki fragments. That was what they were referring to.
Oh, okay. Yeah, yeah, it's the part that you have to lay the primer down before you can make an Okazaki fragment.
Mm-hmm. That is for now.
Oh, no, it says so the RNA primers for the leading and lagging strands. DNA polymerase is what puts together the two strands after RNase takes the RNA primer away.
Well, sorry, what do you mean? Like puts the Okazaki fragments together,
Or not the Okazaki fragments, but yeah. Well, so to make your Okazaki fragments, you have a bunch of RNA primers, and then there's RNA that comes after them, right?
Right.
And then the RNase takes away the RNA primers, and then the DNA polymerase brings the two primers, like where the gap between the two, like where there's two Okazaki fragments, and then the gap where there used to be a RNase gets put together.
Okay.
All right.
The videos I felt were a lot more helpful this week than the reading.
Okay.
Okay. Yeah.
Gonna have to watch those.
Yeah.
Well, I've got lots of free
All
time
right.
now, so.
Okay.
Alrighty.
Okay.
One or
I think I asked all my questions.
okay.
I think we're good. Yeah.
Yeah, I think I'm good. Okay, cool. 2.
Fill in the blanks. I gotta grab my fill in the blanks.
Don't you guys ever get sick of these?
Nah.
Nah.
That's prep. I don't know.
Let's see. The first one's talking about a protein complex synthesizing primers in eukaryotes. I thought that was DNA
That was
primase.
what? DNA primase?
A DNA primase.
I thought it was RNA oh. Yeah, RNA primase, but I have no idea. Let's look.
Yeah. It sounds like there can be, or it is in the opening for the question, that there can be more than one correct answer. So, just putting it out there. That's what I was thinking.
Okay. Hold on.
Yeah. Okay, so I think there's 2 possible answers for this. I think that's DNA primase and DNA polymerase alpha complex.
Okay.
Well, one of those I think is used for eukaryotes, and the other is prokaryotes. But hold on.
I was thinking the alpha was part of the polymerase 3. Is that what it was? The holo, whatever it called. Find the word.
I'm not sure, yeah. On the answer sheet from the practice problems, question 7, during the elongation phase of DNA replication, so it's talking about eukaryotes. It has DNA primase and DNA polymerase alpha. So this is what it says. It says this multi-subunit protein complex contained 2 major subunits, DNA primase and DNA polymerase alpha. DNA primase forms the first 10 nucleotides of the primer, while DNA polymerase alpha forms the remaining 20 to 30 nucleotides of the primer. I don't know again. I mean, that I might just be jumping on an answer there that I really don't know about.
Well, we can come back to it.
Okay.
Is everyone okay with moving on?
Mm-hmm.
Okay. So the next one, part B, is asking about a protein that promotes separation for the AT-rich sequences within the ORIC, or whatever you call it, thing.
Wait, hold on. What did we end up deciding on? Sorry. For A.
That's okay.
We're coming back to it.
Oh, okay. I got confused for a second. All right.
Does anyone else want to suggest an answer for this one? Or
Well,
do you want me to just
promote separation sounds like helicase, but then all that other stuff after there looks unfamiliar. So hold on.
I was thinking it was DNA A proteins. I don't remember where in the notes it said that, but it said it, so I went with it. Let's see, this is the one that separation. Or maybe it's not.
Oh, yeah, DNA A. DNA binds, or DNA A binds to the DNA A block sequence within ORC. DNA A then promotes the separation of the DNA strands within the AT-rich regions of ORC.
Yep, I agree.
All right, we good with that?
Yeah.
Yeah.
Sweet. So part C says looking for the subunit of DNA polymerase 3 that contains proofreading activity. I was thinking it was epsilon subunits.
You know, that sounds dang good.
Fantastic.
Where are you guys at are you in the notes?
Oh, let's see.
There's it's
you know what page?
Crap, there's
a lot of pages.
1, 2, 3,
The
4, 5,
on
6,
like
7. I'm on the 7th page of the note.
4, 5, 6, 7.
It's under DNA polymerase 3 holoenzyme. Holo?
Okay, yeah, there we go.
Yep, and that says epsilon, the epsilon subunits of DNA polymerase 3 poses proofreading activity that fixes mistakes.
That is a dang good answer.
Woo!
I am all for it.
Yes.
Yes.
Okay.
D.
So on the part D, we have a protein synthesizing the leading strand in eukaryotes. I was thinking that this was polymerase 3 subunit something.
You know, that sounds good as well.
Everything's fantastic today.
Yep.
And that's one way to look at it.
Alpha, right? Polymerase 3 subunit alpha. Alpha subunit.
I didn't write down any particular one.
Oh, okay, you just left it at polymerase 3.
Yeah.
Cool. I can dig.
Yeah, it probably is the alpha one, just because that's what they wanted us to find on the first question. So.
It makes sense.
Yeah.
So.
Alpha, yay.
So alpha, okay, that works.
Yeah, I'm just going with the flow.
Wouldn't it be nice if there was an alpha key on the computer?
I'm still trying to figure out how to write it down on paper.
I think of it like a half, like you're writing the infinity, but you start like
but you
2/3
sentence.
It's difficult.
Yeah.
I probably struggle a little more than needed.
All right. So moving on to part E.
Hey,
this one I'm not sure about.
Is Sheila alive? Can she hear us? I just see her right there, but It doesn't look like anything's kind of going on there.
You there, Sheila?
I'm
Yeah,
gonna say
can
no.
you guys hear me?
Oh,
Yeah,
yep.
we can hear you now.
Okay, if we can hear her.
Sorry.
All right.
Yeah, my Chromebook is having a lot of issues, but I can still hear you guys.
Okay.
Okay,
We just want to make sure we didn't do the whole thing without you. All right. E. This
Yep.
protein DNA displaces DNA polymerase 3 from the chromosome to terminate replication. To terminate replication. What?
I'm positive.
Telomerase?
Mm-hmm.
That sounds right.
Because it's part of
Let's check.
the termination replication or termination. What? English. Huh. Something that displaces polymerase 3, but it didn't say like word for word exactly what I wanted.
Let's see.
Yeah, I'm good with telomerase. Right?
Okay.
That just adds to the 3' end, or the 3' end cap, or whatever.
Yeah.
Yeah.
Yeah, I'm also good with that.
Yeah,
Sounds
let's do telomerase.
Yay. Part F. We're looking for a protein that has 5' to 3' polymerase and 5' to 3' exon nuclease activity. I was thinking polymerase 1.
Cool.
Yeah,
Yay.
good.
G. It's asking for a protein that introduces negative supercoils into the DNA. At the head of the replication fork, I was thinking it was topoisomerase type 2, or the DNA gyrase,
Yep.
whatever you'd like to
Yep.
call it.
Sounds good.
Yeah.
Wait, what?
It's the topoisomerase type 2.
Oh, yeah.
Mm-hmm. And then H, we're looking for a protein that binds directly to ARS elements. And I'm not positive. I think this one's the Origin Recognition Complex, or ORC.
For H?
Yeah.
Yeah, I think it is.
Okay.
Whoops. What did I do?
I don't know. What'd you do?
I just figured out a cool trick on my computer.
Did you
Apparently
figure out
I
how
can-
to write in Greek?
Something like that. No. But I flipped my screen
Whoa.
by 90 degrees.
How did you do that?
That's
I
impressive.
clicked Control R.
Oh,
Try
yeah.
it later.
All right, everyone, Control R. You know, I have a Mac. Maybe that's why it's not doing it.
Oh, if you use
I don't know.
Mac, you use Command,
Oh yeah, it would be Command R.
I would imagine.
But I'm in a Microsoft application right now, so let's get out of that. Command R. No, it's giving me that sound when it doesn't like what I'm doing. That's the sound.
Let's see. What were we on? H. So
I, right?
I, yeah.
Okay, sorry.
This one I'm not
We said
positive
ORC.
about.
We said ORC. ORIC.
No, ORC.
ORC. Origin or
Oh, called
an
Replication Complex.
Is it all
Or
capital
recognition.
letters?
Yeah.
All right.
I is asking for a protein preventing DNA strands from annealing. I was thinking this is single-stranded DNA binding proteins.
Yes, that is
Yes.
true. That was the one that was
Okay.
on.
What is it?
Yes.
SSBPS. Okay, 2 big S's. Big B, big P, little S.
Yeah.
J.
And then J is the enzyme that seals Okazaki fragments into a continuous strand, and I was thinking that was DNA ligase.
Yeah.
DNA ligase is right.
Woo! Party.
Do you want to go back to A? Or
Oh, right.
figure it out now, or?
Yeah, I'm gonna just stick with DNA primase. Because it's what sizes the primers, I think. Because I don't, unless it's DNA polymerase 3, but I don't think that's the case. Or maybe it is. I'll think about it.
Wait, so you're putting DNA primase?
Yeah.
Okay. I'll trust your better judgment.
Well, thank you. Very brave. Okay. Question 3. All right. This confused me, so I may be overcomplicating it. But we're looking for stuff in relation to DNA replication. So the part A is asking for 5 enzymes that consume ATP during DNA replication.
Yes. Hold on. Well, we got at least some of those from the other homework. Where did I put my other homework?
Yeah. DNA AA, DNA helicase, DNA gyrase, DNA primase, and DNA ligase.
So DNA A, DNA helicase.
Yeah.
DNA what?
Gyrase, also known
Gyrase.
as the topoisomerase type 2.
Okay.
DNA primase, and the DNA ligase.
Okay.
Okay.
All right. Hey, guys, I've got to run.
Okay.
But sorry for cutting out early.
Alrighty.
But thank you. Good luck with the rest. And until next week. Bye.
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 Okay. DNA. So it's DNA primase and DNA ligase.
Mm-hmm. Yeah.
Okay.
So part B then?
Yes.
Okay, so this one's asking for enzymes that consume DATP during DNA replication. And this is where I may be overcomplicating. So I just put down DNA primase 3, DNA polymerase 1.
Yes, those are both true.
But then I wasn't sure about anything else.
It says list 5. That's
so I was thinking.
Problem.
Huh?
It says list 5 though.
Yeah, so maybe one is like the alpha, beta, epsilon, etc., because there would definitely be 5.
Oh yeah.
But I can't think of anything else, or at least I can't think, and I can't use control find to discover anything else that uses DATP.
Yeah, my control find does not say other findings either. So I don't know.
Yeah. Maybe I'll just put them down, just because they're part of the holocase, or the holo enzyme, which is DNA primase 3. And they make it up, so that would give the amount needed, or that they're searching for.
So would you just put alpha, beta, gamma, like all of those then for DNA polymerase 3? What does it say? List 5. Okay. Yeah, but then there's a bunch of different ones for 5. Do any of them say they don't use ATP or DATP? I don't think so. Okay, we'll put that then.
Wait, you said the only 2 ones you have was DNA primase 3 and DNA polymerase 1?
Yeah.
Mm-hmm. Yeah, because that's where, if you look into the instructor notes, those are the ones that literally say it. So if you look at DATP,
yeah,
it talks about polymerase 3 consuming, polymerase 1 consuming, and then the third thing it brings up for me is talking about chemical mechanisms.
Yeah.
So I'm, yeah. We'll go back up to there. But anyway.
So are you thinking about putting all of those on there then?
Maybe. Yeah, probably.
Okay.
Because they're part of it. It's a multi-subunit enzyme. But those are polypeptides. Those aren't enzymes. Or enzymes aren't polypeptides. I'm not sure.
Yeah, I don't know either. I mean, subunits of the enzyme. It's not.
Come back
Let's see what Google says really quick before we say anything.
Yay, Google.
All right. Huh. Not seeing anything right now. Yeah, I don't know.
Google didn't really say anything.
No, I'm not finding anything.
Yeah, I just go and look at some of the videos that other groups have posted.
Okay.
If they have anything, and if they do, I'll just text everyone.
Okay.
If you guys don't get to
Thank
it.
you.
Thanks.
Yeah.
Because then they'll also explain it. Okay.
3,5 exonuclease.
Yep. This one, another one that I was like, DNA polymerase 3? Because it literally says it for that, but once again, that's why I'm like, maybe I just need to put the alpha, beta, everything. Except for that does 5 to 3, not 3 to 5.
It says, let's see, it's DNA polymerase has it because it says it in there.
Mm-hmm.
Yeah, I'm only seeing those two. So DNA polymerase, I guess. This says 5, so DNA polymerase is 1, I guess.
Mm-hmm. Hmm. Exonuclease. Okay. So we definitely got DNA polymerase. Is there anything else? Let's see. In the how do you say it? I was looking. I did control find for exon nucleases, and the third and fourth one deal with the telomeres. I don't know if those would be a possibility, but they probably not, just because they're just talking specifically about the 3' single strand hangovers.
Yeah, that sounds possible.
Yeah, it's got 3' in there.
Oh, but telomeres, it's not an enzyme, so we can't, right?
That's a good point.
It's just a part. I don't know.
They prevent linear chromosomes from fusing together and prevent degradation by exon nucleases in the eukaryotic cells. So exon nucleases are things that attack or degrade or destroy. What does this one do? Let's see.
Exo. Yeah, I mean telomeres has it in there too, so I don't see why not.
Yeah. Well, looking back at one of the other areas, where it literally says 3 to 5 or 3' to 5' exon nuclease activity is underneath proofreading in the DNA polymerases. And so I think it might be anything that has like underneath proofreading, like anything that helps with proofreading would be something that does that.
Okay, so what do we have for proofreading? So telomeres do that. Telomeres proofread. Let's see.
Epsilon does it in polymerase 3.
Oh yeah, DNA polymerase 3 also, I guess. So epsilon would? Oh, yes. Wait. So DNA polymerase 3.
What is that symbol? Is that delta? I don't think it's delta. This one that's a circle. It's a little leg. Very descriptive. Oh, it is delta. The delta apparently does it in the polymerase.
The polymerase 3, delta, and epsilon.
Yeah. It was talking about it later on in the notes. Let me get back down there. For example, some sources state that DNA polymerase delta synthesizes both the leading and lagging strands. Both DNA polymerase delta and epsilon contain proofreading activity. So,
well, that's 5 right
that
there.
Is my
Okay, I guess let's put those 5 down.
So I put DNA polymerase 3, including the delta and epsilon, and then telomeres.
Yeah.
Okay.
Let's put those down.
Okay.
Well, luckily the next two we only have to find one thing.
Yeah.
The first or part D wants us to indicate one enzyme involved in replication using DNA as the template to synthesize RNA. So I was thinking maybe just polymerase 3 because it's job kind of.
Yeah. Yeah, I'd say so.
All right, because then The second one I'm not positive about, but I was thinking telomerase. Or I wrote down telomerase. Don't ask me why I wrote it down. I just found it. Telomerase contains both RNA and protein. RNA portion of telomerase can form bonds, overhang DNA.
Yeah, I see why you put telomerase. I'll just put that one down too, because I see it now.
Yeah.
It's in the second
back
to the last paragraph of the whole document.
Oh, it literally is.
Yeah. Okay.
Yeah, but I'm still probably going to look that one up just to be positive. All right. Well, question 4. I haven't done this one, so you have to forgive me. But I can at least say which ones are DNA and RNA. Because this one's asking more. They have a lot of information at the top, but really they just want us to determine the sequence of the DNA strands synthesized if we use the nucleotides described in parts A through D in this experiment, which is the first paragraph. So if it can use it, I guess we state if it can, because if it's we assume that if the DNA polymerase cannot incorporate a nucleotide into the nucleic acid strand, the reaction will terminate after the last incorporated nucleotide. And we're not supposed to write down the entire sequence of the primer in our answer. So part A has the nucleotides in this reaction include DATP, DCTP, DGTP, and DTTP, which deals with DNA. That's all I got.
I'm so lost.
I know Sister Mills did a video on this one. I just haven't watched it yet. So
oh, she has a video?
Yeah.
Blessed.
In the announcements. So if you guys want to, I wouldn't have a problem with it if we just skipped it.
That is totally okay.
And then we'll watch it. Yeah, we just have to talk about them, right? And then.
Yeah, we talked about how we don't know what to do with this one. End of story.
Yeah, I don't know how to do with it here. So.
Yeah, because it's a lot of information, and yeah, if you're not supposed to write down certain things, I don't know what I'm not supposed to be writing.
Yeah.
Okay, so then question 5. So we got a list of terms and then questions to go with those terms. So part A is asking which proteins are found in prokaryotes.
So do we just put one of those terms in for A? Is that what it is?
Yeah, I think we did something like this for another group homework.
Yeah. I'm pretty sure though, like we put like as many as the above that apply to that question, and a lot of them can be used more than once.
Yeah.
Oh, okay. But
so, dealing with prokaryotes, the proteins that are involved, the DNA replication is more complex than the replication in prokaryotes. So, let's see. However, the good news is that the replication process is similar in prokaryotes and eukaryotes, and many of the DNA replication proteins, helicase, primase, and polymerase, identified in bacteria have eukaryotic counterparts that function in the same way. So, everything.
All of them?
Well, maybe not literally, but anything with an A's that, or whatever. Yeah, proteins, all proteins. So which one do they want?
Okay, so what are all the proteins?
So it says, at least in that first paragraph of the origins in eukaryotes, it talks about how they have similar in, what is it, that last sentence of the first paragraph, saying that there's helicases, primases, and polymerases in bacteria also.
Hmm.
So we got our DNA polymerase. Let's see, so that's gyrase part of that? No. So it's like DNA polymerase epsilon. Got DNA primase. DNA polymerase 1. Oh, why must one write all this down?
So DNA polymerase, DNA primase 1.
Yeah. So I'm just going down the dotted, or the list that they give us.
Okay,
and
so
MCM helicases, but it does say that there's helicases involved with prokaryotic.
so probably that.
Yeah. I'm just not sure what the MCM is for.
I don't think that's even in the notes.
Well, if that's the case, then maybe we shouldn't put it down.
Maybe it's just helicase and not MCM. I don't know.
Is helicase a man? My man crush Monday.
Polymerase alpha. Polymerase 3. Everything. But anything else, I don't know if it would also be involved. I'd imagine so, because like it needs a way to start, stop, and all that.
Yeah.
It might have a telomerase. Let's find out. Oh wait, those are the only two parts where it says prokaryotes. Oof, duh.
I think it is.
Okay. Oh, there's MCM. So it's the MCM stands for mini chromosome maintenance.
What? Okay.
Yeah, sounds cute. Anyway, it's something that once replication is initiated by the release of a CDC6 and CDT1, MCM helicase catalyzes the separation of the two parental DNA strands. So it helps with prepping for replication. Literally, it's underneath replication initiation. Why didn't I see that sooner? Okay. I'm going to go with that for right now. So we can...
No telomerase?
Oh. Yeah.
I'm not going to put it. Okay.
Because that way it has something to stop the making. Okay, so part B is asking for proteins found in the mouse musculus, or how do you say it? More or less mouse. So eukaryotic is what I was thinking. Anything involved, which I would imagine all of this would be involved. We just have to find the proteins, which I think is everything.
Literally?
Possibly. I think
Wonderful.
there's a few in here where it's like the PCNA. I don't know if that's a protein that's involved, or, well, that would be used in this PCNA. Oh, it clamps, yeah. So I'm just going to put all.
That's fair.
All in list. Calling it good. I don't want to write it down. It's like, if anything, let's see, what's the TUS? The TUS. That is a termination utilization substance. So maybe that one might not be, because that's not a protein necessarily. Well, maybe it is. It binds the stuff.
I'll say excluding TUS, I guess.
Yep.
Well,
okay.
yeah. Wait, what?
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 Oh,
I don't know.
The TUS, just looking it up, I was like, well, let's see what this is before I officially declare that I'm going to say all of them, which I already have. But it's something, it doesn't talk about being, oh, I guess they are called proteins. That's the first word in the sentence. I just need to read.
Preach.
Stand on my soapbox. I'll tell it to the world.
Yeah. Which of the above proteins is involved in chromosome compaction?
No, does not like the word compaction. Fine. Go to let's see. Let's see. Well, PCNA is not part of it because it's part of the elongation phase. So I don't think that one is.
This one's hard.
Yeah, this one involves a lot of knowing your terms, which I don't know.
Well, MCM, that's mini chromosome maintenance. Would that be a part of it? It has chromosome MCM.
This is true. Let's see. What part of? Because I'm thinking that maybe when they talk about compaction, like, even though we can't look it up easily, I think it would be part of like the final stages of dealing with the chromosome. So I was thinking maybe like telomerase or something. But because the rest of it's used for like making things, essentially. Let's see. Let's look up MCM. Yeah, because that one's dealing with, I think MCM helicase would actually go well with part D, because that one's talking about stuff that's involved with the initiation stage. So I'm going to write that one there. Okay, so we got that one. This would also involve, just looking at that first section where it's, because now I'm on part D, because it's convenient. It's right in front of me right now. Regulatory proteins like CDC6 is part of it.
Of what?
Of the initiation stage.
Oh, do we move to D?
Well, just because we were talking about MCM helicase.
Oh, okay.
And so I looked it up, and it's actually part of the replication initiation. And so I just have it open. So forgive me. I moved on. But I'm going to come back to the other one because I have no idea. So that one's part of it. Is there anything else? TUS isn't a part of this. I think those are the only two involved with initiation in the list. Pardon me. Yeah.
Okay.
So part B is nice and easy.
So everything else would be in termination, wouldn't it? Wait.
Oh, with part C.
Mhm.
Oh, awkward. Yeah. Okay, we're good. Yes. No. Well, I think telomerase is definitely with part E. With the termination stuff.
Uh-huh.
Forgot there was a part E. I didn't write it down. All right, so I'm just gonna look up termination. E. coli. Oh, so TUS is part of it. Just in that first paragraph.
Okay.
It talks about how TUS is a protein that binds to TER sequences, i.e. termination sequences. And it also displaces the replisomes from 2 replication forks. Other things that are involved. Let's see what's down here. Okay. DNA ligase. Oh, gyrase? What? Usually 2 daughter DNA molecules are intertwined like the links in a chain. These intertwined DNA molecules are called the catenines, or however you say it. These must be separated prior to the division of the E. coli cytoplasm. DNA gyrase must cut one daughter DNA molecule past the other daughter DNA molecule through the beak or break and seal the break to generate 2 separate daughter molecules. So possibly DNA gyrase.
Mm-hmm. I'm putting that one down.
Although E. coli, that's a prokaryote.
Yes.
Yeah.
E. coli is a prokaryote.
And I guess it doesn't specify which. Okay, never mind. So, oh, here we go. G. There we go. Okay. Yeah. All right. Well, I think that's it for part E. So we have a few questions and question 4 to go back over.
What about C? Did we finish C or?
No, that was one
okay.
that I wasn't sure if we had finished, but I was going to go back to regardless. So.
Okay.
Let's see what we can find.
What would be another word for compaction? What's that?
I don't know.
Maybe would it just be part of initiation then?
Well, we would want it to be lengthened out during. I don't think initiation would be what we want.
Okay, there's elongation. Initiation wouldn't be it. Origins.
Something that helps put it back together. Let's see. Someone's got a very vocal kitty and it's amusing me. Let's see.
Yeah, I don't know. I'm just gonna do more research on this after this about chromosome compaction because I don't know enough about that stuff.
Yeah, I'm in the same boat. But if anyone finds anything, will we agree to text the other?
Yeah, text the group chat.
Yeah. Okay.
All right.
Then, shall we call it a night?
We shall call it a night.
Yep.
Alrighty. Then I will see you all sometime next week.
Yep.
Okay.
All right. Have a good night.
Thanks for everything. Do you know how to post a video or?
Yes. I should be able to do that.
Thanks for that.
Yeah. Alrighty. Have a good weekend.
You guys too.
All right.
Bye.
See you guys. Bye.